All right, welcome back. We're going to be doing a little shopping investigation today with Lego kits. We're also going to see how to draw a true line of best fit using a linear regression analysis using Desmos. Let's get started. Before we launch the activity, let's talk about the statistics driving our lesson. We saw previously that a hand-drawn line of best fit presents several limitations, the most important being that everyone's line of best fit is just a tiny bit different, meaning it's not suitable for doing true data analysis for business, science, engineering, etc. Instead, we use a formal method called linear regression, which uses an established mathematical procedure for generating a line of best fit. The best part is that this feature is built into graphing calculators like Desmos and most spreadsheet software like Excel or Google Sheets. So you will not need to do this calculation by hand. Instead, you're going to learn how to ask Desmos to do this calculation for you. What you will need to be able to do, however, is interpret the output or result of this calculation so that you can apply and make sense of the results. We will be generating our own dataset today based on Lego kit pricing data. You'll be selecting 2 franchises or themes and then choosing at least 4 kits from each of those 2 themes. Next, you're going to use LEGO's official website to gather details about each kit. You need to know the piece count and the suggested retail price, called the MSRP. Make sure you don't use any sale or promo prices because that will throw off our calculation. I'm going to show you a little bit more about how to do that in a few minutes. Once you've collected and entered your data, you'll be using Desmos to plot each ordered pair. X is going to be the number of pieces and Y will be the price. Then you're going to create a line of best fit using this command highlighted in the pink box. We are asking Desmos to draw a linear equation, y equals mx plus b, using the y data from the column marked y1 and the x data from the column labeled x1. This tilde replaces the equal sign and will be the cue for Desmos that you will want the calculator to create a best fit line for the data. I want you to focus on 3 key items for the output. First, notice the slope, m. That will be the rate per piece. In other words, this output implies that the cost is $1.35 per piece in the Lego kit. The y-intercept, or b, tells you the additional or non-piece count related costs. This might be packaging, marketing, transportation of the product to the store, or possibly promotional prices if we were accounting for that sort of thing. Last and most importantly, we want to look at the correlation coefficient, r. Not r squared this time. That's something else we'll look at in a future lesson. Remember that the r value indicates the strength of the correlation and its direction, positive or negative. Now that we've covered the background details, let's talk about the activity itself. I'm going to suggest that you open 2 tabs on your browser, or you could use your phone for research and your browser to enter data on Desmos. Use the link provided on eClass or use the link in the description below. Once you get there, you will be greeted by a Ready Player One, and you can go ahead and click through to the second screen. I've already set up a template for you here, so all you need to do is enter the data. On the left, you can see that X represents the number of pieces and Y represents the price. Desmos is already ready to draw the line of best fit for you once the data is entered into the table. You will also notice that the graphing window has already been pre-configured for you, so don't make any adjustments in this area for now. Now we're going to go to the official LEGO store website. I'm going to go to the top bar here and mouse over the word themes, and then select anything you like. I'm going to pick Harry Potter this time. I've got several lovely kits here in a wide range of sizes and prices. What I'd like to do is select a wide variation of kits. So perhaps a cheaper kit with probably fewer pieces, and then something really big, maybe a Hogwarts castle that has hundreds or maybe even 1,000 pieces. For each kit you select, you're looking for 2 things. The official Lego piece count, for this one that's 6,020 pieces, and the official Lego price. This time that's $399.99. I'm going to enter that data into Desmos for each kit. Now, I'm not going to be rounding anything here because the software is perfectly capable of handling the 99 cents, and I want my result to be as accurate as possible. Anytime I round, I add a bit of uncertainty or error to my calculations. Notice as soon as you enter the first kit, Desmos will calculate the line of best fit. So far, we have a slope of about 6 or 7 cents per piece. Let's add one more for this demo. Alright, I've just added the night bus and our values adjusted based on the added data. You'll want to collect data for a minimum of 4 kits across a broad range of piece counts and prices. But if you collect data for additional kits, your analysis will get more and more accurate. One last thing, make sure that you're logged into your GCPS Google account as you're completing this so that 1, your work is saved, and 2, I can view your submission in real time. You won't need to do anything special to submit it beyond completing it as instructed. Good luck. I look forward to seeing what you find.